All right, so I'm live with the Google Professional Machine Learning certification that I'm going to dive into each week. And I think this particular week, what would be kind of fun to play around with is to talk a little bit about problem framing in more details here and get into that. And it might be more of like a whiteboard kind of lesson here. And so what I can do is just start off with doing some whiteboarding. So let's go ahead and do this, and we'll say share screen, go here, and here we go. So one of the issues that is going to come up a lot with any kind of machine learning certification would be this concept of problem framing. So let's go ahead and dive into that. So we'll call this problem framing. Problem framing. And in particular, what's kind of fun about it is that we have the ML approach, which is here. And the reason why people like to use machine learning is that we actually know what it is that we're doing. And so in the case of, let's take a classic problem of we have some data that is a price uh, data here, and we have basically the quantity. So we'll just say QU as a quantity, and if we're able to try to figure out, like, how many items could be sold at a particular price, for example, and we have, I don't know, 3, 5, 3, and the price is $5, and maybe this one is $3, and this one is $4.90. We could use these things together, and we could create a model that was able to potentially predict what would be the right price to sell items in our inventory, right? And so we could say that our target would be that we would want to say price. We would want to do a target variable that predicts the price that people will purchase our product at. And so in this case, because we have historical data with the machine learning system, that it's actually kind of a straightforward problem, we would do a regression and determine a model that actually predicts the price. Now, if we go into another scenario where things are a little bit more murky, we may not want to use machine learning as the solution to it. So a great example of where machine learning wouldn't be a great fit would be to think about the traveling salesman problem or heuristics. And so if we look at the case of a heuristic, the idea is that there is no perfect solution, right? So no perfect solution. And this is one of the issues with a heuristic, is like we don't know. We don't know what the perfect solution is. And basically the traveling salesman problem, or TSP, is a perfect example of we don't know the perfect solution, and we have n number of cities all over the place, and we want to figure out our goal is to figure out the shortest distance. So instead, what we do in those scenarios is we go through and we build out heuristic type algorithms. And so in this particular one of the best ways to solve a heuristic is to actually use greedy type algorithms. And all a greedy algorithm means is that you find a solution that's good enough for that particular problem at hand. And so if we had two distances, and this was 2 and this was 3, you would always pick the first one, the shortest one. And then the next time, if this one is 3 and this one is 4, you would also pick the shortest one. and then you could do a simulation, and then that simulation would find the total distance, and you would want to do a minimization. And so this is just an important thing to be aware of, is that when you're doing machine learning, you want to determine whether you need to use heuristic first, and that actually might be a good approach before you get into machine learning. And many times machine learning, like in the case of traveling salesman problem, isn't the perfect solution, because there is no known perfect solution. Another one that's kind of an interesting one that I'll talk about briefly in terms of problem framing is the recommendation engine. So let's take a look at the rec engine in terms of machine learning. And if we go here, the recommendation engine, the core concept here is that you want to have, let's say it could be users or content, and you want to actually recommend more of each, right? Right. So that's kind of the concept is you want to build a goal, and your goal would be to be, I think a lot of companies, whether it's good or not, for a goal, there would be engagement. And so in order to increase the engagement on their site, so how often people are participating, they want to recommend either users or content to somebody that's currently on their platform. And this is an interesting problem because there are machine learning approaches to this, but one of the real problems initially when you're framing this is that, what do you do if you don't actually have a lot of data, or ground truth data? For example, how could you recommend content to users if you never have had the ground truth data for the content that you've recommended, whether people engage with it or not, right? So you have a cold start problem. And so instead, when you have this kind of an issue, potentially a heuristic again is a pretty good approach. And so let's go ahead and take a look at this. If we build a heuristic for recommendation, and in this case we say heuristic for recommendation, well, what would we do? Well, you could actually take a list of all users in a system, and let's just keep track of basically like a matrix. And you could actually have inside of a matrix of users, you could have every user, how similar they are to every other user, right? So inside of here you could say, like, user A is similar to user B, they're 80% similar, right? And then user A is similar to user C by 56% similarity. And so all you do at that point, for a heuristic, it's pretty simple, is that you would find out that between A and B, of the users that they have already followed, what are the users, since they're so similar, what are the differences between A and B, right? And so if A is following X and Y users and B is following the Z user, then you would just recommend these two to B, and then the Z you would just recommend to A. That's it. So you can actually easily build out something that's actually pretty useful to users, without actually doing machine learning at all. Just basically using a heuristic that's a similarity, and then you could at the same time capture the ground truth of what happens, and then you could collect data about what is really happening in your system, and then use that to actually make recommendations. So I know this because I've done this before myself, and I think this is a reasonable strategy for many things. Now, there also, I think, is an interesting thing to think about with heuristics around recommendation engines, which is that one of them is the ethics of the recommendation engine. And so I think ethics plus heuristics is an interesting concept. And what could be interesting is if you look at, again, you're looking at this matrix of similarity here, because now we've made the problem kind of simple, of users, and similarities, is sim- are there users that shouldn't be introduced to each other, right? Because if, for example, you have every possible user in your system and there are millions of users, I mean, it's possible you could identify like basically a toxic type of a user who is spreading misinformation, like an anti-vax information, or harassing other users. And then if you also identify another toxic user in that particular scenario, the good question to ask is it ethical to introduce these two malcontent people to each other, or uh, should you instead basically potentially try to introduce these toxic people to content that is going to, or users that will actually make them, less toxic? And I actually think that we do have an obligation to actually look at this kind of behavior, and the default recommendation engines, and I believe that they all work this way now. They won't say it, but I think like YouTube, Meta, those kinds of systems, they're actually, when they find toxic users, they're not doing it intentionally. They're introducing toxic people to each other. But you could potentially figure out, maybe you either find content that they still would be interested in that's not toxic, like still, so we'll call this non-toxic stimulation. Uh, I don't know, maybe like monster truck rallies or something like that, versus only finding people that are very toxic and then introducing them to each other. So I think there's also some things that we're potentially going to be able to solve in the future by thinking, simplifying problems so they're not just algorithmic, but also thinking about like what is the consequences of using recommendation engines. So those are just a couple things I think that are worth thinking about for the Google machine learning certification, and recommendation engines and heuristics and ethics, which I think are all related to the topic. So that's what I got for this week, and I'll see you next week.